This all really started with an electronics hobby, learning to program Arduino microcontrollers. And from there, I thought I'd build a lightsaber, and it just kept going. The original designs used a Arduino to drive three MOSFETs, which are switching transistors to deal with the power of the LED. I've tried other architectures, but found that to be very successful, and I've stuck with it. On the other hand, the design of the circuit boards themselves has evolved greatly over time. The early versions used an Arduino that was connected to separate discrete sensors and an amplifier and things like that. Though it worked, it was a real mess. Then the follow-on design used what's called a shield to gather together the critical sensors that would sit right on top of the Arduino microcontroller. And then I started fabricating my own printed circuit boards to connect all the components together and cut down on the wiring. And this became very successful, and many generations of lightsaber were put together with the V5 of this approach. The V7 followed, which split the circuit board to more efficiently use space. It actually wrapped the circuit board around the battery. I had optimized that approach as much as I could. And so with the sisters and the Aquatic lightsabers, I switched to SMD components and redesigned the shield from the ground up. Starting with the shield, that is the circuit board, which provides accelerometer and the control of the main LED and indicator lights and all this sort of thing. Okay, this may challenge how many things I can do at once, but I'm going to try to put down a 4.7 microfarad capacitor. So with the sisters design, which preceded this, I switched from through-hole components to SMD, which are a little fiddly, but wow, you can make miraculously small things with miraculously high-tech components. So that's the first one down. I'll go ahead and put in the rest and come back. Now it's simple. All we have to do is wait for the flux to boil, the solder to melt, then the solder to flow into the metal parts of the circuit board and pull it all off before frying $40 worth of microelectronics. Yes, I do just stare here and watch it with a, starting to melt. Watch it with a flashlight. It's like baking cookies. There we go. And here it is, all cooked in the industrial oven. Solder's flowed and cooled, and now this is ready to be attached to the microcontroller and wired to the other parts of the lightsaber. This is the last electrical stage, where everything is put on the test bed, tested out, the software is loaded and run, and all the features are tested. From here it goes to be wired into the carriage. The exterior design is the most purely artistic part. It has the least functional requirements. I can cut things on the CNC to cut slots and holes and things like that, as well as do electrical etching and powder coating to add color. The Aquatic saber uses etching and the CNC, but it all starts on paper. It all starts with design and sketches and iterations, and eventually I'll move those sketches to the computer. So the other big endeavor in the Aquatic lightsaber is it's the first time I used a CNC. The CNC is a Chinese manufactured Elix mill that arrives at a bargain price in flat pack from China. But it arrives with the barest of instructions and no useful software. So one of the joys and challenges was writing Python scripts to control the CNC machine, both to allow it to cut the aluminum and create utility printed circuit boards. It was actually a lot of fun and a real joy, and the CNC revolutionized what I've been able to do with lightsabers, so it's a great new tool to have. Okay, here we are looking at the Aquatic lightsaber getting ready to cut. So the top piece here is a piece of test aluminum coming off the CNC. You can see that was also a test for part of the Tano design, and that's looking really good. The internal carriage, the prototype, to make sure that we have all the dimensions and can check dimensions and everything stays consistent between the internal carriage and the case. And of course the case, which you can see here, I've already marked with some black permanent marker, which comes off really nicely with isopropyl alcohol, by the way. But you can see the general marks about where we're going to cut on the CNC. So always exciting, and the CNC little Alex mill does a great job. However, of course, if I mess up the CNC job, there's generally nothing to do except buy a new case, so this is always a little high pressure too. Alright, I can get this fixtured, which is to say mounted on the CNC table, and we'll take some more video then. Here is the Aquatic lightsaber mounted on the Alex mill CNC machine. Off the camera to the right is the 3D printer, which there'll be plenty of shots of later, but they are symbiotic machines because you'll note there's a collar that holds up the spindle that was printed on the 3D printer, and that effectively increases the Z volume of the CNC machine, and the plates themselves that hold the lightsaber to the aluminum base plate of the CNC is 3D printed. So this sucker is all set up, and soon we will be etching the case. We are in Ultra Saber's case, now modified to have the display and the recessed activation switch. So the CNC went just fine, looks good, it's polished up, and onward to etching the case. Final decals are ready to go. They are designed in Silhouette Studio and cut on a Silhouette cutter. And then I'll transfer them to the lightsaber and etch them with an electrical and salt solution. I'm not going to show that process. I'm not terribly great at chemistry, and I think many people have covered how you do it and the safety aspects better elsewhere. So off I go. Here we are looking at OpenSCAD, which is a computer-aided design tool. It's a strange beast. It uses a programming language to build 3D models. It allows you to describe in a programming language 3D models. I'm a programmer. I tend to lean towards programming solutions, but it's also really wonderful in that it's very parametric. You can set dimensions, how long or how big you want a part to be, just change a number or two and it will recreate a model. Here we're looking at the front end of the lightsaber, the emitter, the switch holder, things like that, but I can very easily turn on the other parts to see it. The internal carriage is printed in different parts and glued together normally. This allows for easier manufacturing. There's only so much that will fit on the bed of the printer, and FDM printers build things up layer by layer by layer, so certain sections are sort of built along the z-axis, lengthwise, if you will, and certain sections are built along the y-axis, which is upwise, if you will. But nevertheless, the different sections are exported and sent to the 3D printer. This is the 3D printer, in this case a FlashForge Finder, printing the back carriage of the lightsaber. We're looking down at the top. It's kind of hard to get a good angle into what it's doing. I've been working with this printer for probably a year now, and it's just magic. It turns the design into plastic. It's also grumpy, difficult to work with, hard to keep leveled, and all the things that 3D printers are, but certainly worth it. Here it is after 3D printing and assembly. putting in the electronics and the soldering is actually a pretty significant step that I don't show in detail here, but all the pieces have to come together and fit and be soldered correctly and adjusted and all those things. But it's a great moment when it's finished and you can turn it on and lights and sound all work. It's hard to know what to say about software since software just looks like text on screen. So I won't go into a lot of it here, although I will say that programming the microcontroller that the lightsaber uses, which is nothing but a small computer, is incredibly fascinating in some ways because of its incredible simplicity. It has no virtual memory, it has no operating system, it has a very limited API set, it has no threads. You are programming and understanding the most primitive form of a computing device, and that is a rare treat in these days of large software stacks and incredibly sophisticated chips. The software itself is rather more complex than you might think. The lightsaber does a lot in terms of timing and turning on and audio processing. It is aware of its UI state and can render different UIs, and the software can be configured to support different hardwares and different versions of the lightsaber. And then there's all the bug fixes and things that is part of writing software. It's all maintained open source. I don't know if anyone else has ever actually used it, but it's there, and I've certainly enjoyed writing it.